Hello, this is the luckiest maths teacher in the world, and today we're looking at recurring decimals. So we've done a lot of work on terminating decimals, and we converted fractions to decimals. So for example, you should all know by now, and I hope you memorize this, that say a quarter equals 0.25. So after the 25, you can put zeros, but it doesn't keep on going. It stops or it terminates. So we call this a terminating decimal because it stops. The numbers after the decimal point stop. If we look at 1 over 9, however, if you put that on your calculator, you'll see it goes 0.0, it goes 0.1111111, and the ones keep going on forever. This decimal number never ever stops. The ones keep going forever and ever. And that's what we call a recurring decimal, okay? So why does that come about? Well, when we did converting fractions to decimals, remember what we were essentially doing is we were finding an equivalent fraction whose denominator is a power of 10, like 10, 100, 1,000, whatever. So remember, for 1 over 4, we want to times the top and bottom of this fraction by something so it becomes a power of 10. Now 4 doesn't go into 10 evenly, so we can't do that. But 4 does go into 100. 4 goes into 100 25 times. So if we times top and bottom by 25, the denominator is a power of 10. So on top, 1 times 25 is 25. And then on the bottom, 4 times 25 is 100. So 100 is a power of 10 because it is a number that has a 1 and then any number of zeros. So we can read this number here as 25 hundredths, or we can write it as 2 tenths plus 5 hundredths, which is how we ended up getting the number over here. So this number here is 25 hundredths also, okay? So why does 1 over 4 have a terminating decimal and 1 over 9 have a recurring decimal? Well, the process I just used doesn't work for 9. So if I just take my fraction 1 over 9 and I try and make it so its denominator is 10, 100, 1,000 or whatever, a power of 10, that won't work. Now, the reason that doesn't work is because 9 actually doesn't go into any power of 10. The more advanced of you will know that 9 goes into 9, obviously, but it goes into 99, 999, 9,999. It always goes into a number that's 1 less than a power of 10. So I cannot times 9 by anything to make this denominator a power of 100, right? So then how am I going to write numbers like this that have a recurring decimal? How am I going to find out what their decimal is if I don't have a calculator? Well, actually what we do is we use this short division algorithm. So I'm going to show you for 1 over 9. So again, consider the number 1 over 9. Now you know, because I've said it a million times, that this line in the middle, called the vernaculum of the fraction, means divide. So this means 1 divided by 9. We can write this another way, basically saying how many times does 9 go into 1, okay? So let's actually go ahead and do this. So because 9 doesn't go into 1 at all, does it? It doesn't go in any times, right? What we're going to need to do is we're going to need to add a 0 in here, okay? But we put it after the decimal point because I don't want to change the number. So I say, how many times does 9 go into 10? Okay, so it goes into 1 0 times, but how many times does it go into this number now without the decimal point? How many times does 9 go into 10? Now what it does is go in once, but there's a remainder 1. So I have to add another 0, so I'll divide it again. How many times does 9 go into this number 10? Again, the answer is 1. Remainder 1. So I put in another 0, and the remainder 1 goes there. So 9 goes into 10 once again, remainder 1. And you can see there's a pattern here. It's just going to keep going on and on and on. 1, 1, 1, 1, 1 forever. Now, when you're doing this short division algorithm, you have to put the decimal point above where the decimal point is in the number. So we have to put it right above here. So the decimal point goes here, and that's how I get 9 equals 0.11111, and it keeps going. So for recurring decimals, we put a dot above the numbers that keep going forever and ever. So for 1 over 9, we could write it like this. So this is exact because I haven't actually rounded it or anything like that. The dot above the 1, this dot here, says that the 1s go on forever and ever. So if 1 over 9 is 0.1, then 2 over 9 will just be 0.2222222 forever and ever. And again, that's exact, okay? So you don't always have the recurring numbers from the start. So, for example, I could do, say, 1 over 15. So I'm going to show you that. So 1 over 15, similar to what we just did, that means how many times does 15 go into 1? So I write 15 into 1. Now again, because 15 doesn't go into 1, I'm going to need to add a few zeros. So now I can look at how many times 15 goes into 10, but it actually doesn't go into 10 again, so I have to put another number. Okay, so 15 goes into 1 no times, it goes into 10 no times, but now I look at how many times 15 goes into 100, okay? Now for doing division like this, you can rely on your calculator if you need, but I want you to try it without it. So 15 goes into 100 6 times. Well, 15 times 6 is 90, and there's a remainder of 10. So what we can do is we can add another 0 and put that remainder of 10 here. That just makes it a bit easier. So now I look again, how many times does 15 go into 100? Well, it goes in the same as before, 6 times, and there is 10 remainder. So I put another 0, I write the remainder. 15 goes into 100 6 times, and you can probably see the pattern now. It goes on forever. So again, decimal points have to align. So I know now that 1 over 15 is 0.066666, and 6 goes on forever. So it's not the 0 that goes on forever, it's the 6. So I put a dot above there. Now sometimes you will have two numbers in the recurring expansion, two numbers that keep repeating. So for example, now I'm going to do 12 over 11. So that's the same thing, it's 12 divided by 11, but I can write this as a mixed number, 1 and 1 over 11. Now to find the decimal expansion, I can just look at this fraction here. It'll be 1 point, whatever the decimal expansion of this is. So 1 divided 11 is the same, it means how many times does 11 go into 1? Okay, so 11 doesn't go into 1 any times, so I put a 0 there. So what I need to do is sort of like when we're doing long subtraction, I need to borrow. So 11 doesn't go into 10 either, so I need to put another 0 here. So 11 goes into 10 0 times. So now 11 goes into 100. Now it goes 9 times, because 11 times 9 is 99, but there's one remainder. So I need to add another 0 and put a 1 there. Again, same problem. 11 doesn't go into 10, so I put a 0 there, add another 0. So how many times does 11 now go into 100? It goes 9, remainder 1. Same issue again. I have 11 into 10, goes no times, so I have to add another 0. 11 goes into 100, 9, remainder 1, and so on. So you can see there, 1 over 11 as a fraction is 0.090909 and so on. So it's the 0 and the 9 that repeat. So 12 over 11, which is 1 and 1/11, will just be 1.09, but both numbers are occurring, so I put dots above them. Okay? So I hope you've enjoyed this video. Please ask any questions. This has been the luckiest maths teacher in the world. Have a great day.